Hello everyone, welcome to Vantage Corner. In this video, we are going to walk through the basic concept of OpenWRT, how to install it on your router and set it up a simple network with OpenWRT. The OpenWRT project is a Linux operating system targeting embedded devices. Instead of trying to create a single static firmware, OpenWRT provides a fully reliable file system with package management. This frees you from application selection and configuration provided by the vendor and allows you to customize the device through the use of packages to suit any application. OpenWRT can be configured using a command line interface or a web interface. OpenWRT gives you full root access to the router and ensures that there are no hidden backdoors left by hardware vendors. Home routers are usually not up to date with security patches. Meanwhile, OpenWRT software components are kept to date, so vulnerabilities get closed shortly after they are discovered. In addition to that, OpenWRT prolongs the life of the router. While many vendors only provide updates for the router until the newer model is released, OpenWRT supports all compatible models for as long as their RAM and flash memory can accommodate the new release. Besides that, the vibrant community of developers, volunteers, and other long-time OpenWRT users are always available to help you to solve any issue. With these above reasons, it's time to make a move and switch to OpenWRT. Are you ready? Let's move to the next section. If you are planning to buy a new router to install OpenWRT, it is advised to look for devices with more than 8 MB of flash memory and more than 64 MB of RAM to allow the full features of OpenWRT installation with GUI. Devices with 4 MB or less flash memory can still install OpenWRT, but the features are limited, and in some cases, there are no web GUI due to limited flash space, and you will have to stick to the command line only. I will put the device selection guide in the video description, so just in case you will need this. This video tutorial was made based on this OpenWRT Quick Start Guide, which is also available at openwrt.org. If you need an updated version, feel free to check out the link. Alright, let's get started. The very first thing we need is the firmware or the build for your router. In order to get that, we need the table of hardware and firmware download page. Let me just open it quickly. Alright, so here we have the table. And we have the brand, the model, the version, the support current release, and then we have the CPU, the target, and a lot of information ongoing here. And on the last page, you have the device test data, which is the main information we are looking for. So in this tutorial, I will be installing OpenWRT on the TP-Link WR841N. So this is the model of the router, and this is the hardware version. This is the hardware version A, and you need to select the correct hardware version before proceed with the installation, or else you may break your device. So just before we proceed with the installation, I will check here. We have a working WAN connection and all up and running. So I just copy the hardware version and then go back to the table of hardware. It's a lot of information, so just go back here, brand, the model. Can we find it? Alright, so we have here a version 7, version 8. This is our current version, and we see that the supported WRT version was 7.01.7. And let's go to our technical data, click on it. Then we have the specific page for our hardware version 8. Alright, now go back to the guide. On the device specific text data page at the bottom, locate in the line called firmware OpenWRT install URL that links to a download file called factory.bin or factory.img file. So this is the file we need to install on the router. So where's the file? Okay. So firmware OpenWRT install URL, this is the file that we going to use in this case. And on the second line, this is the only for upgrade purposes. So you can just ignore it for now. Okay, so I will just download this file. Just hit save it. Alright, now we continue. For this tutorial, I will skip the verify the download firmware file because it's a little advanced for the beginner. So we just skip it and go to flash the firmware. So before you start, make sure that you are connected to the router using the Ethernet cable. And ensure that the OpenWRT firmware that you are about to flash match your router model and it's called something and with factory.bin. Alright, so now just log into your router and go to the system tool, firmware upgrade, and we need to browse our file. And this is the file we have just downloaded and it ends with factory.bin, right? So we just double check here if all is correct, matches your router model and it called factory.bin. So after we press continue, we need to wait a while. Alright, so click upgrade. Are you sure to upgrade the firmware? Yes. Cool. So the OpenWRT installation is in progress. Let's wait for the magic to happen. Alright, so after you have successfully installed OpenWRT on your router, let's navigate to 192.168.1.1 to access the OpenWRT router. And because the root password is not set, you can just click on login to access to the page. And this is the main page you will see after login to it. We can see some of the basic information about the router, such as the host name, the model, which is WR841N, and the hardware version. We also can check the firmware version of the current release and what the version of the LuCI, which is the user web interface. And you will see also the system uptime after the last reboot, as well as the loss of the system. On the memory section, you will see the total available memory and the free memory. As long as the service starts to run on the router, the free memory will be reduced. But now we still have sufficient memory to run the whole system. And on the network section, you will see the status of the network of the one port. And we can see that the one port is connected to the internet and it has the IP address 192.168.3.129, and it is connected for 10 minutes, and the DHCP lease will be expired in 11 hours. The next section you will see DHCP lease. This is the IP address that the DHCP server of the router have assigned to the client computer or devices. So in this case, there's only one device connected to the router, and it will assign an IP address of 192.168.1.102. The next section is the wireless. So this will be the status when you enable the access point, or we say Wi-Fi. But due to the security reasons, after you perform a fresh installation of OpenWRT or LEDE, the wireless is turned off by default, so you need to turn it on. So once you turn it on, you will see the associated station, which will be like the device connected via Wi-Fi, but now the information is not available due to the wireless is still turned off. Alright, so that's all the main information about the system overview, and let's move to the next section. And before we proceed with the next step, I would advise that we change the password. So let's go to the password configuration and change the password. We just set it a new password and click save and apply. Alright, good. Let's try a log out and log in. Perfect. So now let's move to the next step, which is secure and turn on Wi-Fi. The last thing you want to do is turn on and secure your Wi-Fi network. So when you install a new copy of OpenWRT on the router, the Wi-Fi are disabled for security reasons until you have a chance to set up a Wi-Fi password. Let's do that for now. So let's go to network and then go to wireless. On this page, you can see the available radio you have on the router. For some router which have like dual band Wi-Fi, you will have two radio, but in my case, the router had only one radio, which is with a support BGN protocol. So there's only one radio, and let's go and click on edit. Here in the general setup, you will have the mode, which is access point, and the ESSID, which is the Wi-Fi name. So you can change it to anything you prefer, or you can just leave it at the default configuration. And here you have the network. So where this Wi-Fi will be linked to, is it linked to your LAN? So if you have the same IP configuration with your LAN device, or it should be linked to your one. So in my case, I just leave it at default, and I will navigate to the wireless. In the encryption, I will select WPA PS key, and I will just put in my Wi-Fi password. For example, something like AABBCCDD123. So this is my password, and basically that's all. We just click on save and apply. Alright, so we have just made some change to the Wi-Fi to the wireless network, but we haven't enabled the wireless. So let's click here, wireless network, and enable it. Alright, perfect. So we have just turned on the wireless. Let's just go to our status page and see. So as you can see, it has been turned on. So now I will use my phone to connect to the Wi-Fi station, and let's see what happened. As soon as my phone connected to the router, we can see an associated station show up here with the MAC address and the signal, the receive rate and the transfer rate. So basically it's that all. You have just set up an internet connection for the router and you have just enabled a Wi-Fi. Alright, so we have just installed OpenWRT to the router and we have just turned on the wireless on the router as well. But if your device is directly connected to the optical network converter or the GBON modem, then you need to establish a PPPoE connection in order to access to the internet. And in this case, as the IPv4 status is still not connected, we will have to do some of the change on the system. And in order to do that, let's go to network interface. We will see here we have the one interface. And let's go to edit. In the protocol, you have to click on the drop down and select PPPoE. Click switch protocol. So here you need to put in your username and the password that the ISP, the internet service provider, had provided. So I will just proceed with the information that I got and the password. So on the advanced setting, I will just leave everything at default. And in the firewall, it will be assigned to the one interface. That's good. Click save and apply. So we have just successfully established the PPPoE connection, and this is the one IP that I received from the ISP provider, and this is the section of time. So now we should have a working internet connection, and let's just go to speedtest.net and perform a connection test. So its log rate is log that everything has been set up and working correctly. Here you can see the real-time status by go to status and real-time rough. This is the real-time system log, and here is the traffic. So we can see that this is the PR LAN, which is your LAN connection, and this is the PPPoE connection. And as you can see, we have some traffic ongoing. And on the wireless tab, you can see the transmission rate of the Wi-Fi stations. And here, yeah, we can see the physical rate and what the average speed and what is the peak, so that you can have a proper reparation of the network. Alright, we have just successfully set up a PPPoE connection to the ISP. And now it's time to change the system setting. And the first one, we have to change the time. So let's go and change the time zone. We just navigate to my country. It will be Asia, Kuala Lumpur. And click save and apply. Good, so we have a correct time. Why you need to set up a correct time on the router? Because you will need to check the system log later on if there was some problem. So, and by the way, you can check the system log by go to status and system log. And here you can see that all the debug information and what has been going on the router. But here you can see that one of the device has sent a DHCP request, and the router had assigned an IP address, and there was some like DNS ongoing and how is the network happening at the background, so you can have a clear view by check in on the system log. Now we already have a working network, and there will be some other question like how do I forward a port, or how do I open a port on a router? And we will going to do that right now. And before we proceed with the port forwarding, you should have a static IP assigned to one of your hosts in the network. So let's navigate to network, DHCP and DNS, and just assign a static IP for one of the device. So I will assign a static IP to my PC, which is this WAN SD-DS. And this is the MAC address. I will just copy that. So on the static list, you just click on the add button. And the host name, the MAC address, you can just select it from here. So in my case, the MAC ending with 89.99, so we just select it 89.99, and the host name, just copy that. The IPv4, we just select the current one, which is 102, and the lease time. So to give a permanent IP address, you just need to put in 0. After we're done, click save and apply. So we have just assigned a static IP to one of the hosts in the network. And let's navigate to the network firewall to do the port forward. So in the network firewall page, you have 4 main sections: general setting, port forwards, traffic rules, and custom rule. Click port forward. In this page, we have some field to fill in, which is the name and the protocol ID, the external port and the internal port, and the IP address, right? So let's say I'm going to open port 80, which is the web server, the HTTP web server, right? So I will just put like HTTP server, and the protocol is the TCP, and the external zone will be WAN, right? So external port 80, and the internal IP address, you need to select the static IP that you have just assigned to the host, which is 192.168.1.102. And what will be the internal port? So in my case, I will just use 80 as well. So I just leave it there and click add. Alright, so we have just created the first port forward rules in the firewall, which allow the access from any network outside of your router via port 80, and all the traffic will be forwarded to your internal client host name with the IP address 192.168.1.102 and via port 80. So after you're done, you need to click save and apply. The system will take some time to apply the new rule to the firewall, and now you have done create the first port forwarding. By default, after the installation, your OpenWRT router will have the IP address of 192.168.1.1, and you can change this IP if you want. So let us just do it. In order to do that, you need to log into your router, of course. And then we go to network interface, go to LAN, click on edit, and here you will see your IPv4 address, so which is the current web interface address that we are using. So I will change it to 192.168.9.1. So once I confirm all the settings have been done, I will click save and apply. So right now the router applied the change, and it will move to the new IP address. It will take some time to apply the change. Let's just open a new tab, 192.168.9.1. and here you are, and you can now access to the router at 192.168.9.1, and all your LAN IP will become 192.168.9.exact. So now you have changed the LAN interface from 192.168.1.1 to .9.1. However, if you have some of the DHCP static list, then you need to manually edit it. If I go to DHCP and DNS and edit your IP here. So as we can see, the system had not changed the IP, so you need to give it a new IP address, or you need to manually type in .9.2 like this and click save. So once you're done, click save and apply. So far you have just changed your LAN IP address. And now we will establish the SSH connection to the router. So now we will PuTTY to establish a SSH connection to the router. In the hostname, you need to specify your IP address, which is 192.168.9.1, and the port 22. Click open. The username will be root, and the password is the password that you have set for the web interface. And here you are inside the common shell interface. Hi, welcome back. In this section, we are going to set up the router as an AP client. AP client or wireless client mode allows the access point to become a wireless client to another AP. And this AP client will act as a wireless WAN connection for the device in your LAN. For better understanding, let me show you the diagram. So here we have this AP with a working internet connection, and the name is ALSVN, which is the address ID. And our router will be connected to the AP as an AP client. It will get the internet connection and then distribute the internet connection to your host in the LAN or the device that is connected to the OpenWRT router. So, sound like a good plan, and let's get started. The first step, go to Network, Wireless. Now, click on the Scan button. A list of available access points will show up. Let's find our AP, which is ALSVN, and click Join Network. On the WPA pathway, fill in the AP password and give the new interface a name. So I will go with the default WWAN and apply the same firewall zone to this interface. When we're done, click Submit. Now, verify all your information and make sure that you select the correct country according to the FCC law. So once we all set, click Save and Apply. So we just finish. On the associated station, we can see the established section. Here we have the RX and the TX rate. Let's navigate to network interfaces and have a check. As you can see, we have a new interface. WWAN is a client to ALSVN and traffic is passing by. Let's perform a ping test. Good, we have a good response, and this tells us that we have successfully set up our router at an AP client, and we have successfully shared the internet connection to our LAN device. In this section, we are going to run back to the original firmware which were provided by the vendor when you purchase the router. This tutorial is quite advanced, so make sure that you watch, read and understand everything clearly before proceeding, because just a single mistake can cause your router stop working. And yes, for this tutorial we will need Ubuntu or Linux. The first step, log into the manufacturer software download page and get the firmware according to the hardware version of the router. And just another reminder, make sure that the hardware version of the firmware you download matches the hardware version of the router, or else there is a high chance that you may break the router. Cool. This is the firmware that we have downloaded. And the instruction goes, in case the file name of this firmware does not contain the word boot in it, you can simply revert back to the original firmware. However, in case the file name of this firmware does contain the word boot in it, you need to cut out parts of the image before flashing. For the WRA41 hardware version A, we will cut the first 13158 bytes, so which is 257 multiplied 512 of the original firmware. Different models and hardware versions will have different cut bytes, so make sure you cut the correct bytes. Here we have the command to cut. ddif equal the original firmware name of equal the new firmware name ending with .bin skip equal 257 space bs equal 512 and let it enter. The process is completed. Now let's check the file. Cool, here we have the file. So we got the cut version of the firmware on our hand, and there are different ways to install it. I will choose the easiest way, which is update the firmware using the GUI. Let's log into the OpenWRT GUI and then go to System Backup Flash. Select the cut firmware and untick Keep Setting. This is a very important step to clear all the user data when performing the rollback. A checksum dialog will pop up. Click proceed. And the file is being written to the flash memory. Once we're going back to the original firmware, the router will be reachable via 192.168.0.1. Let me just perform a ping to verify that. Perfect, we received the response and it is positive. Let's check out the web GUI. The site says TP-Link Wireless N Router WRA41N as a welcome message after a long journey with OpenWRT, and voila, we have just successfully run back to the original firmware. Hi, in this section we are going to update OpenWRT with a web interface. And the very first step we need to do is get the update file. So let's open the table of hardware and firmware download page. The step is just the same. You search for the model. In this case, it will be WRA41, and we have a list of the different hardware version. And in my case, it will be the hardware version A. So we click on the View tab data page. So here you have the link firmware OpenWRT upgrade URL. So this will be the file that we're going to use to update the software on the router. And the file normally ends with sysupgrade.bin. Once we have the file, let's go to System, Backup, Flash Firmware in order to upgrade. And before we proceed, I would advise to make a backup of your current configuration, just in case there is something wrong and you can restore the current configuration. Alright, so we have successfully backed up the current configuration and it's time to flash the new firmware image. And here you have the Keep Setting option. This option allows you to reserve the current configuration of the system. And for a major system upgrade, it is recommended to not keep the user configuration. So which means we will untick that and all the user custom configuration will be erased during the flash process. But in this case, we're just doing a minor upgrade, so we will keep the setting. And once we've done select our file, click on the flash image in order to start the process. A firmware checksum will pop up and just hit proceed. The system is flashing now. Do not power off the device. Of course, we will not power off. And just in case you want to monitor the process, you can open a command prompt and then try to ping the router, and you will see the process, whether it is running or it will stop at some point. So you can have a picture of it. So as you can see, we have the response from the router. And now the request timeout. So we believe that the router has completed flashing the new firmware and it is in the process of restarting. So let's wait for a while. Alright, so now we receive the reply from the router and we assume that the router is now up and running. Cool, so when the process is complete, we can see that the page reload itself, and we are now in the updated version of OpenWRT. And please remember that when you update a stable version, it will come with LuCI, which is the web interface by default. But if you are installing a snapshot version, then LuCI is not available at the first place, and you need to manually install LuCI via the command line. That's all, and let's move to the next section. In this section, we are going to install LuCI App Statistic. It's an application with the dashboard or the chart, and it will show you some of the nice detail about your historical data. And out of the box, OpenWRT can show you some real-time statistics. However, it will not store the data for historical view. By installing LuCI App Statistic, you can have a nice view of your historical data graph for the router, for example, ping, interfaces, bandwidth utilization, CPU, RAM, and then the disk, and then the system uptime. So first of all, I will show you how to check the real-time statistic that come with OpenWRT first, right? And let's get started. So we will log into the router. And in today's section, I have a new router, which is the D-Link DIR A42C2. So the first step, we go to status and real-time graph. And this is the real-time dashboard that comes with OpenWRT. So we have some of the information like the load, the traffic, and the wireless status and connection. And yeah, we have some of the basic information here. Okay, let's forget about the system real-time statistic. Let's install the LuCI App Statistic. And in order to do that, we will need command line access. Okay, so here we have the command line. We just make it a little bit bigger. Okay, cool. So the first step, you need to install the LuCI App Statistic by using the command line. So OPKG, which is the package management system for OpenWRT. Now the package database has been successfully updated, and let's install the LuCI App Statistic. Cool, so we have just successfully installed LuCI App Statistic, and it's time to install some other plugins. This command will show you the available plugin, and let's install it. Just copy it one by one, hit enter. And then enable daemons. Now we're done, and we don't need to create a default RRD directory because the system will automatically create that for us. So all the collected data will be stored in the RAM disk. So the wraps and the data are lost after reboot. If you want, you can store the collected data to your USB write or to a network write, but it requires advanced configuration. And in this case, we just install the LuCI App Statistic only, so the data will be lost after reboot of the router. Okay. Alright, so once we complete the installation with the command line, let's log out from the management web page and log in again. So once you have logged in, you will see we have a new menu here, which is the static. So we have two drop down menus, which is the wraps and the setup. We need to do the basic setup first. So let's go to it. And here we have the host name, which is leave it at default, and you have some of the basic configuration like where the base directory, and then the data collection interval, which is 30 seconds by default. So if you don't need like too detailed, you can change to like 1 minute. And in the general plugin, we have like the processor, the system load, and the memory. So I will just leave it alone. I will just go to the network plugin. We have the interface, the wireless, and the ping. So in interface here, it will monitor the single interface. So you can configure and you can select the one that you need. And here you have the list of monitor interface. So in this case, I will monitor the LAN interface and the WAN interface as well. Alright, so I will select the WAN interface too. Okay. And then click Save. And the same for the wireless, you can configure the wireless interface of your router and which one you want to monitor. And if you do not specify any interface, the system will automatically find the wireless interface and it will monitor that. So you don't need to worry, and I will just leave it blank and we just save it, right? And for the ping, I will also enable it. And here we have the host to monitor. So I will not monitor the local host for sure. We just monitor like the Google DNS a.a.a.a and then click Add. And now we can delete the first one. And in the address family, you can select either IPv4 or IPv6 or both. But I will just select IPv4 because my router doesn't have IPv6. So the interval for ping by default is 30, but you can change to 60 or you can change to 120. It's up to you. And I will just put 15 seconds because I need the data in order to show to you. So I will change it to 50 seconds. So once we're done, we click Save and Apply. And let's check out what's on the output plugins. So we have some of the tools which is used to record and written down the data in by default is the RRD tool running, and we just leave it blank, and the process will be writing the file to tmp/rrd. We just leave it there. So now we should have a little data here on the chart, and let's check it out. Alright, so here we have a chart, and alright, so here we have a chart and we have a different tab like the processor, the interfaces, the wireless, and in the wireless we have two radios, so we have WLAN 0 and WLAN 1, and the system load and the memory and the ping. So as you can see that we have one small output here. So the system has just performed a ping to a.a.a.a, and the ping response time is around like 3.9 milliseconds, right? So let me just go back to the interface, and then I will try to like run a speed test, and then we will check if there is some like data ongoing on the chart. Let's do it. So the normal load will be 50% CPUs, and I believe that when we're doing the high speed test like that, the CPU usage will increase. And let's see if this And let's see if this statistic are accurate. Alright, so we have just refreshed the page, and as you can see right now the system users have just gone up to 33, and yeah, we can see that the system is writing down data. So let's back to the interface tab and see. And for this interface Ethernet 0.2, which is the one interface, we can see that we have a received data which is 196 megabyte, and the chart it reflects what is going on in the network. And let's go back and check our system log. Okay, so yeah, we have some data ongoing, and basically we can see that the application is running as expected. And you can also change the wrap interval. For example, here we have the drop down menu. You can change to 1 hour, 1 day, 1 week, 1 month, and 1 year. So after you have select a new time interval, select display time span, and it will refresh the graph. Alright, so that's all about the LuCI app statistic on OpenWRT. And if you want to learn more about the advanced configuration, like how to store the data for a long term, then you can check out the link. I will put it in the description as well. And here we have the guide, yeah, how to store the data to the USB or to another host, and yeah, you can surely do that. So this section has just summed up the tutorial series about OpenWRT for beginner. Thank you everyone for your attention. You may ask me, where should you go after this? Well, there is a developer's advanced user guide which is provide a lot of useful information, and you can check it out in the video description. And as always, if you have any questions or idea, feel free to leave it in the comment section so that we can discuss. And if you see the video is helpful, please like, share, and subscribe to the channel to support me. See you all in the next tutorial.